Hey everyone. So here we'll be solving yet another problem on binary search, which is allocate minimum number of pages. Now see what this problem says. So what it says, you are given an array and what it comprises of number of pages of books. So 12 pages, 34 pages, 67 pages, 90 pages. And M are your students. M are your student, number of students. You are given two students and you are given four set of pages, which are this. So what you have to do, you have to allocate these four pages amongst these two students, not more than them. Amongst these two students, you have to allocate the pages. Okay, you have to allocate these pages and in such a way that the maximum a student can get, it should be minimum, it should be the smallest. The maximum a student can get, it should be the smallest. So we have to minimize the maximum. Now what I mean by this, and before even starting this, the fact that should be clear with you, that the allotment here, as you can see, the allotment should be contiguous. It should be like it should be in order. So if you are giving a student one, let's say 12, so you cannot give 90 and you say that I'll give a student two these pages, these two set of pages, and I'll give student one 12 and 90. No, you cannot give. You have to go you have to go in contiguous order. Okay, because here if you see 12 and 19, it's not contiguous. In between it, you are giving it to someone else. So you have to maintain the continuancy. So you have to be consistent among this. Okay, so here are your few possible, what you can say, the distributions of pages, like, and they are, as you can see, they are contiguous. Okay, so in this observation, in this possibilities, like in these possibilities, you see s1 is getting, in p1 s1 is getting 12, s2 is getting this much, and p2 p3 onwards. So what I say here, guys, if you pay attention, so who is giving you the smaller value, who is actually giving you the smaller value, if you see. So what I mean by this, sorry, this is not one. If you add this, it is 191. One, not one, it is not, it is 191. So who is giving the smaller value? Obviously, if you see, the maximum, if you calculate the maximum the student can get, you wrote down here. Okay, 191, 157, 113. And which is the smaller value amongst them? Which is a smaller value? Obviously 113 is the smaller value. Okay, so you will return this answer. You will return this answer. So this is your answer. What? The smallest maximum that a student can get, the smallest maximum number of pages that a student can get. So in that possibility, you'll consider that possibility where if you are distributing your pages to student, all the students, and the maximum that a student is getting, that is minimum, that is the smallest. Okay, so let's see what you can do with this particular problem. So first of all, guys, even before starting this problem, the brute force solution, what I say is, so obviously we can start with allocating pages in linear fashion, 1, 2, then 50, then 100, and what you want, as what this thing is depicting, this number line, you start with 1. So what I say, let's consider the maximum a student can get. So what I say, if I can give a student as a maximum of 1, all the student, if they are having upper bound, let's say this is the capacity number of pages that they can carry, and if I'm saying that you can get only 1, max to max 1, okay, then I will say in this order I'll increase, and I'll say, let's say you are getting max to max at 50 number of pages, and this max I have to minimize. So once you see by increasing, because obviously there will be initial few values where you will not be getting answer. So if you keep 1 as your lower limit, what if you keep 1 as your lower limit, this is not your answer. This will never give you answer, because if you give 1 page maximum 1 limit, no, like it is not your favorable answer. Okay, so what you say here is all the values. Okay, so if you go in forward direction, 50, then 60. So right now you see 113 is the first, like going from left to right, 113 is the first value which you can keep this capacity, their maximum capacity. So all the pages you can distribute. After 113, obviously you're increasing the capacity, then also you will be able to distribute, but as you wanted the smallest maximum number of pages, which is 113. Okay, so you saw this, we'll go linear, we'll go initially linear, and let's say we'll write a function can allocate, where we'll be giving all these parameters, this maximum limit, this pages array, and this number of students. And this can allocate function will tell us that like, is this 50 enough for you or not. You have to go to like, you have to increase the capacity, or is this 50 is enough. But what I say, guys, as you see, are we supposed to go from 1? Can we increase this? Because 1 is obviously is not helpful, and even 50 is not helpful. Why I'm saying 50 is not helpful? Because, guys, if you see, these pages, they cannot be split into like multiple halves. So if you see this 90, you cannot say that I'll distribute 45 to some other 45 pages to some other student. You have to give this entire set, this entire number of pages, 90 pages, to one student. You cannot distribute 90 into multiples like 40 and 50, 30 and 60. No, you have to give this entire set, entire 90 to one student. So if you, let's say, keep the range as 85, if you are saying that I'll not give any student more than 85 page, then how is it possible that then some student will get 90? No, because 90 you have to give in one lot. You cannot say that I'll give one student 85 and there are 5. No, you have to give 90 to one student, all the 90 pages to one student. So you have to make sure what? You have to make sure that your, like, your number line, whatever you are starting from, to calculate that this is the minimum pages I can give. So that you have to start with where the maximum number of pages in that array, the maximum number of pages in that array. And why are we doing this? You saw this. Why are we doing this? Because even if you keep the smaller value than the maximum, let's say you are keeping 80, so 90 cannot be allocated. 90 can never be given to anyone, because 80 is the maximum that you can give here. But how can you give 90 then? Because if you are carrying a container of 80, so, and you are putting it 90 inside, you cannot put 90. You have to break it into 80 and 10. But you cannot break. There's a limitation. You cannot break them. You have to give the entire thing. Okay, so this was the case here. Okay, so 90, you have to start with the container of size 90. Like here, if you have to start with the at least the size of 90. Okay, so let us see here. So what you have to do, as you see here, 12, 34, 67 and 90. 12, 34, 67 and 90. So you have to start with 90 at least. You have to start with 90 at least. Okay, 90, 91, 92, 100, 101, 110. Sorry, 110, I think. And what was your answer? 113. So let's write this. Okay, sorry, 110, 111, 12, 13, 14 and 120 and onwards. Now see, this can be your lower region. Like from here you can start, and obviously we are starting on a number line, so we have to stop somewhere. Okay, now where we have to stop? What I say, what is the maximum pages, what is the maximum limit that you can think? Because 90 was the lower limit, and who was limiting it? The maximum number of pages. And what is the maximum limit that a student can get? What is the maximum limit? Obviously the answer is 113 here, but what is the maximum limit that you can even think of? Because you have to start your loop, correct? You have to start your loop from I equals to like some value till I less than equals to. So what is that I less than equals to? So what I say, the worst case, like there will not reach anyhow, but the worst case would be what? Take all the pages, add them, do a sum of them. Let's say the sum is, hypothetically, I've not calculated it, but hypothetically, if even you can calculate this, 12 plus 191, what is it? 203. Okay, so 203 pages is the maximum. Okay, so what I say, let's give this, let's keep this as the maximum size. And let's see if students can get, like, if we can distribute all this entire array to these two students, keeping 203 as the maximum size. Obviously 203, if you keep this 203 as the maximum size, if you are saying that I can give every student a maximum of 203 pages, now am I able to distribute? Obviously you will be able, because 203 is the maximum size. You can give this entire array to one. But yeah, you have to make sure that every student should get at least one. There is some, at least every student should get at least one book. So, but if you're keeping the maximum limit, let's say you're keeping the maximum container limit as 203 unit of water, and you are saying that can I accommodate these into these students? Obviously, because you are saying this is the maximum. This is not the unit that you have to use. This is not the limit. This is the maximum limit. Obviously, you can go reduce. You can reduce this, but if you keep the maximum as 203 unit, you'll obviously be able to distribute everything, the entire because this is the maximum. Getting it, guys? So you can reduce this. So the maximum can be the sum of array. Okay, the maximum can be the sum of array. Now let's see this. And here I'll be writing can allocate function, and I'll show you how I'll write this. But I'll be writing can allocate function, which I'll be having this few parameters. Now see, you start with 90. Okay, can 90 allocate, like if you keep upper limit as 90, so can 90 able to, if this is the upper range, are you able to distribute these number of pages to two students? Let's see right now. I have my calculator open by my side, and I'll calculate it right now. So I am keeping what, 12, so 90 is the upper range, 90 is the maximum that I can give, because this is what I have to minimize, the maximum. So if I get 90, I know I got my answer. I want to go to right because I have to minimize this. I have to keep it as small as possible. Now let's see. Let's start with this first value. It is 12. 12 is less than 90. Let's keep a variable sum, which was initially 0. 12 is less than 90. So yeah, 12 I can give. So I have to give at max as possible, but lesser than 90. So let's say after 12, what is this? 34. So 34 plus 12, what is this? 6 and 4, 46. 46 is lesser than 90. Okay, 46 plus 67. Obviously, it is greater than 90. 46 plus 67, it is greater than, obviously, 100 and greater than 90. So what you say that S1, yeah, student S1, take this 46 only. Because if I'm giving you 6, because you have to give contiguous. Remember, you cannot escape this and you cannot go to right. Look, this array is not like it is not guaranteed that it will be shorted. Here it is shorted because I don't think in question it is given that it is shorted. So this array can be anything. Okay, so here we are not considering the case of shorted only, that we will short it. No, because you cannot like change the order. You have to give them in contiguous order. Like by default here it is shorted array, but you don't think that in a way that every time it will be shorted. Now let's get back to our this function. So S1, what you said, because yeah, S1 I cannot give you 67 page. This 67 I cannot give you, including all these two page set of pages. So take this for 46 and satisfy this S1. That S1 you are done. With 90 as upper limit, I could have only given you 46. Now let's see for S2 what you give. So obviously this S2 will start with 67. Now the sum is 67. 67 plus 90. Okay, so here again you saw this, that 67 plus 90 is greater than 90. So you will say S2, sorry, you will also get only what, 67. You will not get this 90 right now, because this 90, if I give you, then I'll like cross this upper bound, which is supposed to be 90. Okay, if I'm giving you 90 plus 67, so the container required for this 90 plus 67 is obviously greater than 90. Okay, but I cannot give that because I have the limit of 90. Now what you will say, so so S2, for S2 you'll be giving 67, but again you are remaining with 90. So for this 90, what you will say, I am like having this 90 as a container size, and I'm having remaining with 90. So what you will say, here I need one more student, because I have to distribute these pages. I'm concerning about only distributing these pages. So I'll need one more S3 student. Okay, I'll need one more student. Let's term that as S3. So I'll give 90 to it. Okay, but guys, see here, what is happening? The not a favorable thing. So you have to distribute these three, like for these all pages, into two students. You were given in question right here as two students, but in two students you are not able to accommodate. You used third, because you have to distribute these pages, and you went to third student. So in that case, if your count of students that you want is greater than what you're given m, like number of students possible, you're given m, so you will say what, by return 0. This can allocate function. So what was this is the working of can allocate function, guys. This is how we'll write can allocate. Okay, you saw the working, we'll write that later. So you saw that we required 3, but we only can have 2 students to distribute these pages. So we'll say at 90 yard, if I keep this 90 number of pages as the maximum limit, I would not be able to distribute all these pages up to only 2 students. I will need 1 more, 2 more, 3 more, or something I need. So, and in this way, if you go, because we know that 113 is the lower limit. If I can keep this Like if this is maximum size and this is the smallest maximum size, if I keep this, then only I will able to distribute. So if you go by this, the way we like ran that and can allocate function thing, so prior to 113, all these regions, if this is your upper limit, if this is your maximum limit that a student can get, maximum number of pages the student can get, you will not be able to distribute. This can allocate function will always return what? False. So when you say give, let's say 100 to this can allocate and ask that can allocate, can I distribute all these pages to two students and the maximum size is 100, this can allocate function will say sorry, you cannot. So what I say, these will be your unfavorable zones. These will be your unfavorable zones, which means tell them like your answer is not in this region. Your answer is not in this region. And once you get your 113, once you get your 113, now let's dive in for 113 as well, so that all the confusions are clear for you guys. Let's keep S1 and S2. Let me open my calculator besides by my side. Sorry. So S1. Okay. So sum is starting from 0. Sum is starting from 0. So let's give 12. 12 is less than 113, obviously. So we are seeing this container size as 113 right now. This upper limit that a student, and let's see. Let's suppose that you are dropping these pages into this this particular container. Okay. So 12 you dropped, and 12 is lesser than 113. No problem. You increase sum to 12. 12 plus 34. Again, it is lesser than 113. Okay, no problem. And when you did this 12 plus 34, let me calculate. 12 plus 34 plus 67. Okay, so this is coming 113 plus 67. This is coming 113. Okay, and 113 is lesser than equals to 113. So you filled it to your its top. So you can say that I can give. Let's go for 90. Okay, then 113 plus 90, it is greater than 113. 113 plus 90. So you will say what? S1. So to the current student, you will say take 113, because if I include the other element, why am I including? Because we have to try to keep at max, like as max as possible, but in continuous order. Okay, so you say that S1 to the current student, whosoever is right now it is S1, that take 113, take 113 only, and I'll start with other student. So 113 is done. Now you're remaining with only 90, and 90 is lesser than 113. So you will say by S2, you're also getting 90. You're also, and because you are ending, there's nothing here to its right. So you will say S2 to S2, I'm giving 90. So you saw this, that you were given what? You were given two students, and you require only two students to distribute all your pages, and keeping 113 as upper limit. So this 113 is your first favorable thing. Okay, this 113 is your favorable zone. This 113 is your favorable. Now what I say, guys, if you are keeping 113 as your upper limit, as maximum number of pages that a student can get, and from there you do your can allocate function, it returned you what? 1. That yeah, if you give me 113, you can distribute. Like I'll distribute all the pages, no worries. I'll be keeping 113 as the maximum limit, and I'll be distributing every page, sorry, every set of page. Now if you think, if you think that if you increase the size of this page, then also will you be able to allocate the pages? Obviously, because by 113 keeping this lesser size, you are able to allocate all these pages. Now if you increase this size by 114, 115, 120, obviously then also you'll be able to increase, correct? You'll be able to allocate, sorry, not increase, you'll be able to allocate. So what I say, you'll be able to allocate the pages with increased size than 113. So all the elements starting from 113, all the sizes that you are seeing here, they will be your favorable. So what I say, guys, see this. Right now I was just going with linear search, which is the brute force, obviously. So you'll see what, if you start with 90, and why we started with 90, because 90 is the lowest that you can even take to start with. Okay, and why it is like, what is this 90? This is the maximum in this number of pages array. Okay, so 90, 91, 92, if you go in this order, linear order, no, you will not be getting your answer. Once you encounter a 113, because you want because if are the maximum number of pages that you are keeping, and in that you want the smallest maximum page. So once you encounter this 113, you are done. You will say I'm returning the value, because my can allocate function is giving me 1 right now. Okay, so you will return this 1 at this particular position. Okay, so you will not, in linear search, in brute force, you will not go to any other place. So you saw this, in linear search we got our answer. Okay, but what I did, and what we did, we started a loop from 90 to at worst case it may go to sum, like sum of all these things. But what you are doing actually, you are doing an order of n, which is a linear search, which means you're searching, which you're searching for. And if you're searching something in linear time plus the space is shorted, look, I'm not bothering about, like, don't bother about this space. I'm not saying this space is shorted. This may be unshorted. This is like random. But this search space is shorted. Okay, this search space 1991 it is shorted, and you are doing that linear search, not linear traversal. You are doing linear search. Then what is the approach to go for maximum? Sorry, to what I can say, optimal solution. It is binary search. Okay, because binary search is built on top of what? Linear search on shorted space. So as you remember, guys, all my videos, what I do, once you figure out that I can go for binary search, now what's your next task? Your next task is to divide the first into two parts. And you see, we have already divided into two parts, unfavorable and unfavorable. So favorable is like, the favorable zone is that zone where can allocate function will return what? 1. And unfavorable is that zone where your can allocate function will return 0. Correct. And you know, L is your this range and H is your maximum sum. You also got this. So you have to calculate mid values all the time. Okay, so let's see this. Who will give you answer? And I always keep this, like, keep saying this, that L and H will give you answer. Finally, L and H will give you answer. So what you want, what is your answer? Answer is your first favorable, which is first element of second space. And you know, when your binary search will end, who will point there? Let's see, when binary search ends, what's the position of L and H? As you know from part 2 video, and we also did a couple of questions, that L will, when binary search will end, the opposite, if it is like L is in first space, so L will go where? The first element of last space. And H will go where? Last element of first space. This and this. Who will give you answer? L will give you answer. You also got this, that like your return, you'll return what? L will you return? L you will return. This will give you answer. And let's see one more thing, a few more things, not one more. So if your mid is unfavorable, where would you go? You'll push, because you have to find your first favorable, so you'll push your L to right. Obviously you cannot go to left, because you have to find the first favorable. You have to find, look guys, that is why I say, once you are done with transforming this number line in this unfavorable and favorable zone, you ignore this. You don't need this number line. It will only confuse you. And see guys, this is number line is not that you will be building it in some array or what. No, this is what, when you write this if and else condition in binary search, this number line will automatically be divided into these two parts. It's just that how you divide, you are seeing this right now. Okay, so you ignore this number line right now. So what you want, the first favorable, you know, it will return, like it will be written by L at the end of binary search. But we are seeing the mid values. If your mid is unfavorable, where you will go? Because obviously you cannot go to left, you will go to right. So you will push mid, you will push L to right. So L is equals to mid plus 1. And if you are at some favorable, let's say this 114 or this 120, so obviously you cannot go to right, because you have to find the first favorable. So you'll go to left if you're already at favorable. So if you are at favorable, which means your canallocated function is giving you 1, you will push what? H to left, which means H to mid minus 1. You will push H to mid minus 1. Okay, we also saw in like where we have to move and how we have to move. The only job remaining to us is can allocate. Now let's see how will we write this can allocate function. Okay, let me write it right here. The working of this can allocate function, how will we write this function? So as I'd already written on like previously, we solved this, but let's see. So you'll keep a count variable as 0, and let's keep a variable pages that a current student is getting. Obviously it will be starting with 0. Now let me write this this for loop I less than pages. Let's say you're getting n as the size of this array. Obviously we are solving on Geeks for Geeks, and they normally don't use vectors, they use arrays. So you'll be giving n semicolon I plus plus. So this is your loop. Now what I say, if what are you doing, if you are like your current number of pages to the student plus your incoming page, let's say your a of I, if it is greater than mid, if you cross this boundary, you want certain number of pages, let's say 50, and you cross that boundary, you cannot allocate. You can allocate this current page. So in that case, what you have to do, you have to increase the count plus plus. You will say that, yeah, this variable, this first count plus plus, here count was 0, count was 1, count became 1. So student 1, I am done with you, I am done distributing these pages with you, because if I give a of I again, a of I more to your number of pages that you were already given, you will cross the upper boundary, the maximum. So you will do count plus plus, and at the same time your pages now for the other student, the next student, the student number 2, right now the pages will start from this a of I value, this a of I value. And in else, if you're not crossing the boundary, if you're not crossing the boundary, then in that case what you'll say, take these pages again, because you have to fill as maximum as possible, but keeping this 50 as the upper limit. So you'll say what, your pages for that particular student will be plus equals to a of I. So you'll say take a of I as well, because you're not crossing the boundary. So here you're crossing the boundary, here you're not crossing the boundary. And finally you'll end this loop. So now guys, what I see, if you remember that once you end this loop, even you can see from here itself, even you can see from in this loop itself, that once you are ending the loop, you are remaining with pages, you are remaining with few pages. You see, if also we are writing, look guys, this is how you write, this is how you write the correct code, even like before getting wrong answers and everything, just handle these things. You see that we are writing these pages, like we are putting some pages in both if and else condition. If and else condition, we are putting pages, some pages we are remaining with. If you see this, let me use some other pen. You see this, pages we are remaining with. So what does this mean? This means when you are ending with the loop, so you are remaining with some pages, and for that also you'll use one student, you have to use one more student, correct? So you will do, once this loop is ended, you have to do what, cnt plus plus to distribute this remaining page, because in this if and in this f in this if and in this else, we saw that at the end in both the blocks we are getting some pages left, we are remaining with some pages, and that too we have to distribute. So this count plus plus is for that, the final count plus plus after this loop is ended. Now what I say, if you require, if this count is less than equals to what you require, the number of students, if you require less student or equal to student, then this allocate function will return 1. Else, what this means, you are given with 2 students, but you require more than 2, which is 3, 4, 5, then you will return 0, that I cannot distribute this. So here you see the working. And guys, remember, you have to distribute at least one set of page to everyone. But here you see what I said, if you require less student, than what you're given, then you'll return 1. But as I said, you have to distribute the pages to every student. But what it means, consider this scenario, a simple analogy, and you'll get this. Okay, let's take a beaker container which is having a size of 100, and you are said that you have to fill let's say what, 200 unit of water 200 unit of total water inside these 2 beakers, and it is compulsory that you have to fill. So let's take this size as for 400. Okay, so you have to fill, you are given only 200 unit volume of water, and you have to fill both the beakers. Compulsorily you have to fill both. Some water it should be inside, and this is what this question is also saying, that you have to distribute some pages to every student. Like every student should get at least one set of page. And right now, but you are taking the range, this beaker volume. If you give 200, this 200 will be accommodated in this volume. This 200 will be accommodated in one volume itself, one beaker. Then you will say that, yeah, I'm not able to distribute this 200 in both. But what I'm saying, guys, as you saw in this number line, this was the maximum. 400 was the maximum that you could distribute, that you can take the size, the page size, or here the beaker size. From 400 you can go down, you can go to 100, because this is the maximum size. Look, for distributing 200 volume in 400 volume size, you need only one, but you have to fill 2 beakers somehow. You have to fill 2 beakers, otherwise you cannot do this answer. Okay, you cannot go with this solution, because you have to distribute one page to at least a student. That is what here, if you see, guys, student should be allocated at least one book or one set of pages. So, but what this is the maximum. If you go to a lower limit, this is the maximum. Obviously, if this is the maximum, then obviously you can think of a lower size. Let's say 100. If you keep the 100 size beaker, then 100 here, 100 here. Okay, so this is what this particular solution is saying, that if you are able to distribute, like taking upper size, if you're able to distribute this entire thing, don't worry, you will be able to distribute, because You can obviously reduce the size of this beaker. In that case, you can reduce the size of these pages. You can remove, like, reduce the number of pages. But what our concern is, can this 200 volume can be distributed in 400 or not? If it is yes, then return one directly. Don't do all these things, because even you can reduce the size and do all those stuff. So all in all, what I say, this is the working of your this can allocate function. And we saw that whatever number you require as a student, is if it is lesser than what you are given, you can allocate. If it is greater than like, if you require more students than what you need, then what you have, if you need more, it will return 0. Now let's see how my thing works, like how I wrote these functions. So obviously this can allocate function, I hope you got this, guys. And if you see, we are returning -1 somewhere. And what is that? If your m value, number of students, let's say it is 4, and if you are only given 2 set of pages, then how can you distribute these 2 set of pages to 4 students? Because you cannot break them. So if 4 is greater than 2, which means number of students is greater than number of books, you will return -1. And here h and l is what? Maximum of the range. If you see, 90 was the maximum. Okay. And h is what? The sum of the values, the sum of all these pages. And you guys can see that I'm trying to keep this, while this binary search, as neat and clean as possible. Just keep this. And also this is a type 2 question, obviously, because we are deciding favorable and unfavorable depending on this function. So here you see I calculated the mid. This is can allocate function. This can allocate function will give you true, like favorable or unfavorable zone. If it is true, you are in favorable. So this is your favorable, this is your unfavorable. You see, guys, when you were in favorable zone, where would you move? Obviously you cannot go to right. Like, let's say you are in favorable zone, you cannot go to right. You have to go to left. Why? Because you have to find the first favorable. In that case, what you have to do, you have to push your h to left. H is equals to mid -1. Okay, h equals to mid -1. And same you can say for this l. If you are at unfavorable, where would you go? You'll go to right. You cannot go to left. In that case, what you have to do, push l to right. Okay, push l to right, which is mid +1. And finally you'll do what? Return l. We saw that we will return l. Okay, I hope you got this, how I wrote all these things. Do let me know in comments that is this question simple for you or not. If this question is simple for you, always consider the number line, yeah. Unfavorable and favorable space, that's it. Once you divide that favorable and unfavorable, remove that number line and remove all those array and everything, then it will be simpler for you. Let's meet in some other problem then.